Hello, and welcome to this presentation, Getting Started with the CMA180 Spectrum Analyzer. In this presentation, we'll explain how to configure and use the Spectrum Analyzer function of the Rohde Schwarz CMA180 radio test set. This presentation assumes a basic understanding of spectrum analyzers and their most important measurement parameters, such as center, span, reference level, resolution bandwidth, etc. If you're unfamiliar with these topics, or if you'd like a brief review, you might want to watch the presentation Understanding Basic Spectrum Analyzer Operation before beginning this presentation. The CMA180 Spectrum Analyzer option, K120, enables two different spectrum analysis modes. The first of these is frequency sweep mode, in which the CMA measures and displays power as a function of frequency. The second is zero span mode, in which measured power is shown as a function of time. Zero span mode is covered in a separate presentation. Frequency sweep mode is a general-purpose application that can be used in many different ways, some common examples being measurements of harmonics or other spurious emissions and signals transmitted by the radio under test. To select the spectrum analyzer scenario, click on the global toolbar and then choose Spectrum under the Analog tab. Once the application is started, press the folder icon to toggle between Split Mode, which shows the generator and analyzer applications side by side, and the Merged Mode, where only one application is displayed at a time. The device under test can be connected to either the RF COM or the RF in connectors on the front of the CMA. This is selected in the RF Settings tab under Spectrum Configuration. Note that these two connectors have different maximum input power levels, 100 watts continuous and up to 150 watts maximum on RF COM, but only plus 20 dBm or 100 milliwatts on RF in. An external attenuation value, either from an attenuator or from cable loss, can also be specified. Note that this RF connection is the only one required for spectrum measurements, although other types of connections can also be made. For example, an audio connection to supply an audio frequency signal to the DUT audio input. Let's look at the main spectrum analyzer screen. The buttons on the right side are used to start, stop, and pause the measurements. At the top of the screen are the most important measurement parameters. In the center is the power versus frequency display, and at the bottom is the table of marker values. In the remainder of this presentation, we'll go through each of these areas and explain how they're used in performing spectrum analysis on the CMA180. The four most important parameters for spectrum analysis are shown and can be configured at the top of the main screen. The center frequency of the display is chosen using frequency, and span is used to specify the measured frequency range, centered around this center frequency. The expected power values should be configured slightly higher than the maximum expected input signal power. This is the same as reference level in many spectrum analyzers. And finally, the RBW or resolution bandwidth setting will influence the resolution of the measured signal, the noise floor or displayed average noise level, and the time it takes to complete one sweep. Please see the separate presentation Understanding Basic Spectrum Analyzer Operation if you'd like a more detailed explanation of these parameters. By default, the CMA scales the X or frequency axis and the Y or power axis automatically. These can, however, be manually scaled directly from the main display by clicking on the icon shown. Note too that the CMA also supports zooming in on an area of the display using the standard click and drag technique to draw a box around the area of interest. In addition to the four basic parameters, additional spectrum analysis settings are available by clicking on the configuration icon in the bottom right corner of the screen, and then choosing the tab Analyzer Settings. Here, the span can be configured as start and stop frequencies, and video bandwidth and sweep time can be manually entered as well. The configuration icon in the results area can also be used to specify various parameters, in particular the detector type and the averaging mode. Note that throughout the CMA, a green check mark next to a value indicates that that value was automatically set. This is common for some spectrum analysis parameters. In particular, sweep time generally should be left at the automatically configured value. Spectrum measurement results can be displayed using 4 trace modes. These are enabled by clicking on the global trace modes icon on the right side of the screen, and then enabling each trace type individually via a checkbox. These different trace types are color-coded and can be displayed simultaneously. The default trace is current, which shows the power measured during the last measurement interval or sweep. Average shows the average of the last n measurement cycles, where n is configured by the user under RF statistics. Max shows the maximum value since the start of the measurement. In this example, we see what appear to be spurious emissions, which occurred to the right of the main carrier frequency at some point in the past. And finally, min shows the minimum value since the measurement start. This can be helpful in finding continuous signals near the noise floor. Markers can be used to obtain precise numerical values from the trace. These are enabled by clicking on the marker icon on the right side of the display area. There are 3 types of markers: reference markers, as well as markers showing absolute values, and values relative to this marker. Markers can be placed manually by entering a numeric value, and they can be placed and adjusted by clicking and dragging on the display. There are also marker search functions, which we'll discuss on the next slide. Numerical values for configured markers are shown in the table at the bottom of the screen. As mentioned a moment ago, marker search can be used to place markers according to user-defined values or criteria. A common example of this would be automatically placing a marker on the highest or the peak value of a trace. Another common application is searching for peaks to the right or left of the current position. A peak search can also be performed over a specified search range. Furthermore, it's possible to adjust the display axes based on a marker value. We'll look at an example of marker search on the next slide, but please see the CMA180 documentation for more details on the different marker search functions. Here's a quick example of using markers. A peak search was used to find the carrier, which is at 150 MHz. A delta marker was then manually placed at 300 MHz to measure the level of the second harmonic, and the numerical results show that this harmonic is approximately 62 dB down from the carrier. Note that although in this example we're placing our markers on the current trace, it's also possible to use markers on other traces, such as the average or maximum trace. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can perform both swept frequency and zero-span measurements when equipped with the K120 license option. In this presentation, we focused on frequency sweep mode, with zero-span mode being covered in a separate presentation. The device under test can be connected to either of the CMA's 2 RF input ports, although be sure to observe the maximum input power for each port. Swept spectrum measurement parameters, such as center, span, RBW, etc., are all user configurable. Measurement results are shown as traces of power versus frequency, and multiple trace types, that is current, average, max, and/or min, can be displayed simultaneously. The CMA's marker functions can be used to obtain precise numeric values from a trace, and these markers can be placed manually or automatically, both as absolute or as relative markers. And finally, the CMA supports a variety of marker search functions that can be used to locate peak values, etc. This concludes our presentation, getting started with the CMA180 Spectrum Analyzer. If you'd like to learn more about spectrum analysis, the CMA180, or other CMA180 measurements, please see the links in the video description.
Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.